All right. Looks like we are live everywhere. It's a good thing.
Hey, are we really live? We are live.
We are live. Yes. I've checked all three. So we are on Facebook, YouTube, and Twitch as well. Now you have more than one way to stream Ruby Tuesdays. We're a bit early, but I guess we can kind of start it off with the keynote. So yeah, welcome everybody to Ruby Tuesday 75. Today is 3rd of November. Oops. Right, this Ruby Tuesday is brought to you by both KL Ruby Brigade and Penang Ruby.js, and as well as engineers.my. Join our Facebook group if you're not there yet. Meetup is a place we constantly update our events as well. GitHub, if you're interested in sharing any Ruby code you're working on. Slack is where we kind of communicate most of our events as well, so definitely join there. We've been using Discord for our the code events. So because it's kind of like the only platform now that allows unlimited call time. So if in the future we have any events that requires interaction, definitely join Discord. Right, I'm Gui, everybody, one of the co-organizers of Ruby Tuesday. If in whatever platform you are on right now, feel free to comment or chat. Right, we'll definitely see those coming in through StreamYard. Okay, hiring shoutouts. I think we have a few. One is by Fort Ninja. It's a cybersecurity startup. They are hiring experienced Ruby on Rails developer for a remote role. I think Gui will share the job description in the Facebook group later. So yeah, I believe Faith is hiring as well. So that's definitely one company to consider. Okay, today we have two talks. So one is Learning Sidekick by me, and next up is Web Bluetooth by Tristan. Yeah, I guess we can kind of dive right into it then. I won't be able to see the comments or chat when I'm kind of presenting. So like Tristan or Gui, just feel free to like shout out to me or something like to grab my attention, I guess. All right. Learning Sidekick, better understanding the background processor. So hi everybody, I'm Gui. So let's learn more about Sidekick today. I didn't spend a lot of time on this slides, unfortunately, so it's going to be slightly more wordy. So today I'll be talking about what is Sidekick, some very simple code, and also mostly about the internals of Sidekick. Quick about me. So I'm a software engineer. If you attended one of my previous talks, I used to say I'm after 6 p.m. Rubyist. Now I kind of I'm in a job that does Ruby day to day. So, well, let's see how this goes. Most of my social media handlers are Ghosted Human. So if you want to find me anywhere, just look for it there. Right, let's talk about Sidekick. So what is actually Sidekick? Sidekick is a job processor gem. So basically, very simply, it takes some job that is in a queue and process it. Sidekick runs in two modes. One is a client mode, which uses the Sidekick Worker module API and calls the Sidekick client class. So this is the most commonly used mode when you're writing on a web application, for example, Rails or even Sinatra or any other framework, to send job data to be processed. Right. Server mode is the mode where Sidekick actually takes the job and actually runs the processing of the job. Some simple illustration, basically Sidekick client serialize the data from the web server, sends it over to Redis to the Sidekick server. So how do we use Sidekick? Very simply, just create a class with a Sidekick worker, right? Use the perform method to kind of like write down what you want the job to do. Right? And then from there, once the job is instituted, you can kind of like do a synchronous call, or asynchronous call, or even a delayed asynchronous call. So I won't dive too much into the code on how to get Sidekick working. But let's dive deeper into how does Sidekick actually run their internals. I think this, I hope some will find this useful. So let's talk about the Sidekick server Bootstrap. So as I mentioned earlier, in the server mode, bin/Sidekick in the server mode, it started when we run the bin/Sidekick command. Right? So the bin/Sidekick calls the Sidekick CLI, which performs all these things when it's actually bootstrapping the server mode. Right? It will validate all the bootstrap arguments. So all the arguments that we pass in through bin/Sidekick, the gem will kind of validate all that argument, make sure it is within the permitted boundaries, is in the correct type and such. And then it will continue to boot Rails, if you're connecting to Rails, that is. From then on, it will connect to Redis. So all the arguments related to Redis, for example, the connection pool, the Redis configuration, even Redis version, Sidekick actually runs a check during that bootstrap time to make sure that, okay, I can connect to Redis, the connection pool configured is what is passed through, and that sort of thing. Sidekick also eager loads the server middleware. So I'll sidetrack a bit by talking more about the middleware. So earlier we have a diagram where we have the web server and the job processor. So Sidekick relies heavily on middlewares on both ends, in the web server and the job processor as well. So in the web server, it will rely on the client middleware, and on the job processor side, it will rely on the server middleware. So usually the middleware is the one to decide whether or not to pass the job to Redis or even to accept a job from Redis. We don't usually touch this much unless you have like specific configuration you need to do. But during this bootstrap, it will eager load the server middleware. From then on, it will set up the signal handling. So this is mostly for OS level signal handling, right? For example, if you're hosting on Heroku or EC2, Sidekick also does handle any OS level signals. So it knows that, okay, Heroku is initiating a shutdown. I'm going to bring down my service, that sort of thing. So the final thing it does is actually starts the launcher actor. So the launcher actor is kind of like the main component inside Sidekick server. So I'm going to talk more about the actor model, right? Besides the fact that Sidekick itself uses actor all over. Also with Ruby 3 coming, I'm really looking forward to Rector, which is Ruby's implementation of the actor model, even though it's experimental. So let's talk about the actor model a bit. So the actor model is actually a model to deal with concurrent computation. Right? Actors are a primitive unit of computation. It is a thing that receives a message and perform computation based on that message. Right? So actors are isolated units from each other and they don't share memory. And how they pass on message with each other is they have mailbox. Right? So they store messages while it's processing another message. So if you're looking at this and you're thinking, this sounds a lot like object-oriented design. Right? An object receives a message, which is like a method call. Right, does something depending on the message it receives, which is like what method is being called. So it's really much similarly concept like objects in object-oriented design. I think that's like an easier model to map to if you feel it's a bit confusing dealing with actor model. So an actor can only do three things, right? It can create another actor, it can send a message, and it can also designate what to do with the message, like basically how to process, what processing to do when it receives a message. Right, I included an image here so that it's slightly clearer. So actors are always in a system, right? They won't be just a single actor. It's always multiple actors working together, which is how it's being used for concurrency as well. Right? As I mentioned earlier, they don't share memory, so it's kind of like memory safe. And a lot of things they perform, especially the messages they get, are immutable as well. I definitely have a link down in the reference where there is a blog post about 10 minutes understanding actor. So that's like a very good beginner guide to actor as well. So why am I talking so much about the actor model? Well, because Sidekick uses actors heavily, as I mentioned earlier, right? Sidekick was using Celluloid before version 4. So Celluloid is actually a gem that implements the actor model as well. It's not an active project right now, if I'm not mistaken. So, but definitely look out at that. It's on GitHub. A major overhaul to the actor system in Sidekick was done in version 4. So I included the PR link as well. And they are like blog posts by Mike Perham, the author of the PR, about why he decided to move away from Celluloid. Celluloid wasn't bad, but for Sidekick's use case, they managed to shrink down a lot of the things they didn't actually need from Celluloid and make their system a lot leaner. He even performed benchmarks to show that it's actually faster by implementing their own actor system rather than relying on Celluloid. So let's see how Sidekick heavily uses actors. Basically, the whole Sidekick process is run on actors. There are 4 main actors in Sidekick, which are the launcher, manager, processor, and scheduled poller. Right, we'll go through these actors one by one, and we can kind of break down like what are each of their functions and how they interact with each other. Okay, as I mentioned in the Bootstrap earlier, the final part of the Bootstrap is the launcher actor will start. So what is the launcher actor? Well, the launcher actor is a very simple actor whose job is to basically monitor the other actors in Sidekick. Right? It bootstraps as I mentioned earlier, it bootstraps the actor system at the end of the Sidekick server initialization process. And because its job is to monitor the other actors in Sidekick, if any of the main actors die, the Sidekick process exits immediately. So you can think of the launcher actor as the main actor. Right, next up we have the processor actor. So processor actor is a standalone thread. Basically what it does is it handles all the job processing in Sidekick, right? This is the actor that actually fetches jobs from Redis, runs the job, right? If it needs more actors, it will insert the worker actors. This is the actor that also interfaces with the middleware as well. And this is the actor that calls the perform method, the code that we write that runs the job. A processor can exit as well due to shutdown or error during job execution. So if there's an error in job execution, the processor actor will call the manager actor to create a new actor to replace itself. So remember, actors aren't threads or aren't processors, right? They are merely just like objects passing messages to each other. So that's why they can always, it's usually safe when they need to create another actor or call another actor to perform an action. Right, let's talk about the manager actor. So the manager actor is like the central coordination point in Sidekick. So the manager actor handles the lifecycle of the processor actors and feeds them the job as necessary. So what a manager actor does is it will spin up processors, which we understand earlier. They are the actors that actually run the jobs. Right. So the manager actors also handle job failures. So if a processor actor comes in and say, hey, a job failed, the manager actor can kill a processor and then create a new one to replace it to retry the job. It will also handle shutting down either processors, or even if there is a processor actor that is having an issue, it will just hard stop the processor. Okay, let's look at the polar actor. So the polar actor is basically the actor that checks Redis and then pass on the job to the processor actor. So sometimes there are issues where, for example, retried or scheduled, where we need to some actor needs to look back into it, right? So polar actor is the one that if there's a job that needs to be retried or when it's time for a scheduled job to run, the polar actor will pick that up and then pass it on to the manager, and manager will let the processor actor to work on it, right? So polar actor is also the one that pops the job back to the original queue, so the workers can pick it up like any other job. Yeah, like this is kind of the gist of what is happening inside Sidekick. I think it's very dense, but it helped me understand a lot on how Sidekick actually runs internally and the whole actor system that they use. I included a lot of links here as well. Definitely, like, feel free to read of it. As I mentioned earlier, like Mike Perham, one of the authors of Sidekick, he basically talked about why they're moving away from celluloid, how they're implementing it, and a lot of all this information I actually just got from the public code. Like the code is like very clean, and a lot of things were very easy to follow. Yeah, I'm looking forward to Ruby 3's release of Fractal as well as I mentioned. It's going to be an experimental release, but having built-in actor support in the language is very, very powerful. That's all from my end, actually. Thank you. Tristan, you're muted.
Sorry, do we have any questions from people?
I
I see there
don't
are a few people on YouTube, on Facebook, and on Twitch. Oh, people are on Twitch. Interesting. Ren DG just said like our stream. Thanks. So, are you cool? Do you have any like resources you wanted to share? Maybe you can share the last slide that you had as well.
Yeah, I
People
can
just wanted to
bring it up slightly longer.
take a look at it.
How do I let me yep.
Yeah.
Yeah.
Will you be maybe we can put this as part of the show notes as well later.
Yeah, I can add it as
So
a
Sidekick is
and yeah, sorry, go ahead.
No, I was just commenting that Sidekick has been one of the biggest and most used workhorses of the Ruby community since it was started. It was so it like you mentioned, it was originally um, Rescue, and then Mike Perham just decided that it was like it can be a lot better instead of doing like a single process thing, and then you can do a multi-process server, and then it's compatible with Rescue as well, the binary protocol that they're using with Redis. So this is actually quite a very useful thing. And for people who want to have the links, we'll have this on the show notes later. All right. Next one, I will be going next. So this is web Bluetooth. So this is not exactly Ruby related, but this is also, well, later on, I will show the Ruby version of Bluetooth. And because Penang Ruby is jointly, the presentations for Penang Ruby is jointly with the JS community there. So I thought you should, like, since this is this particular meetup is together with the Penang community, then maybe I should also show a bit of the JavaScript stuff that we've been doing. So, Gui, if you're there, do you mind if we go for a small workshop? So I would like this as a small workshop as well, because you already have everything that you need, except for the people who have iPhones, because unfortunately, Apple does not like people who develop on their platform and don't do apps like native apps. They are all gung-ho on native apps, and so they don't really give like the necessary permissions for example, Chrome to access Bluetooth. But if you have something like an Android phone and like a Chrome browser, one of the later Chrome browsers, then you'll be able to follow along. So I will share my screen now. How do I share my screen? There you go. Share an application window. StreamYard. Share. All right. If you can download this application called ELE Peripheral Simulator, which I will run phone, which I will be running as well, then that would be good. So we can start it because we are actually going to be connecting to simulator to Bluetooth devices, and most likely because you don't have an actual Bluetooth beacon, for example, that will advertise battery services in this case, then we will be simulating it. But if you have actual devices, like for example, if you have heart rate monitors or those things, then you can try that out. So let me know if you've installed this, and then we can start. All you need is Chrome. You'll see there's Chrome, and it will do everything on the console. All good? Yep. All right. So, first off, like quick, uh, a quick, what do you call this? Introduction on Bluetooth. Uh, this is so Bluetooth low energy. We're actually doing Bluetooth low energy. We're not doing the Bluetooth classic. So that was like many years ago. Like usually on these wireless earbuds or on your wireless keyboard, you're usually using Bluetooth classic, and that's a serial replacement. So instead of cables, you're using wireless. So it's a point-to-point communication. Whereas Bluetooth Low Energy is different. While you can use Bluetooth Low Energy for point-to-point communication, which is what we're going to be doing now, it's also a lot more. You also have models where you have a broadcast and observer, and the point-to-point would be like your client and peripheral. So what we're doing is the client and peripheral. I'm talking about the classic and the low energy because they're different. They're not compatible with each other. So whenever we talk about Bluetooth Low Energy, the concepts there are very different from Bluetooth Classic. So in Bluetooth, most of the documentation are in Bluetooth.com. So this is the Bluetooth SIG, this special interest group. You can go through the site and then take a look at how Bluetooth is evolving. But Bluetooth Low Energy, the client peripheral thing that we're talking about, there's a lot of like aspects there, but this particular one we're talking about, we have this concept of services, characteristics, and values, right? So imagine like where you have a server, so which is the client, you connect to that, and then that server will have a list of services, and under those services there are groupings that will fall under those services will be characteristics, which you can then either read from or write to, or you can even get notified if something changes, or all of these things, right? What we're going to do is we are going to connect to, so if you have your application, turn it on and then go to this screen. So basically, this is the peripheral simulator. We are going to be connecting to the battery service. And so what this will do is it will create a battery service that you can connect to. All right. So now we have the screen, right, on the console. What we just need is everything for Bluetooth would be the navigator.bluetooth namespace. So first check if you have navigator.bluetooth. Because if you don't have it, then you might need to enable experimental web features in your browser. If you have it, like it shouldn't like, for example, if you run Firefox, let's see, let me run Firefox, inspect element, it will say navigator. So it won't even have, so Firefox doesn't even have the Bluetooth property on navigator. All right, so make sure that you have this. So that means you have Bluetooth functionality. You have your browser supports web Bluetooth. Now, web Bluetooth is all promise based, and so we are going to be using a lot of promises. Right? So what you will do is you assign a device. So let device equal navigator.bluetooth.request device. Now request device accepts an options object, and what we're going to be using will be filters. And this property accepts an array of options. All right.
Jason, maybe you can zoom in the code a bit.
Oh,
it's like,
all right. Sorry. How about this? Is this fine?
Yep, that's better.
Is this all right? Yeah. Okay. Right. So filter accepts. Filters. Oops. Filters accepts an array of objects, and what we're going to be doing would be something called services. And services accepts an array of either UUIDs or service strings. And what we're going to be doing would be something called battery service, right? Everything good? And when you press enter, you are going to be taken to this screen. So we'll say this page wants to pair, and then it will show all of the devices that has the battery service on it. If you have more devices on your house or within your general area that has a battery service, this will show up here as well. You'll see that it shows my my phone because I'm running it right now. You click on pair, and the device, the promise will resolve. Well, it hasn't resolved yet because we haven't resolved it yet, but now we're basically paired with a phone, right? I'll copy this and I will paste this on our chat as a comment. I don't know if this will work. Will this work? I guess that works. All right. All good. Now, what we want now, so we want to resolve the promise and assign the result to a server because we want to connect to it, right? So this is the device where we assigned the result of this to a device. It's a promise and we want to resolve it. So we want let server equal to, so we have device. We resolved the promise. This d dot get dot connect. So we connect to the device. So device resolves and then we connect. It's not going to say show anything, but what we're going to do now. So now we have the like this hierarchy again, right? So we have the device, we have the server. We want to get a service from that, and specifically the battery service. So we want let service. Let me copy this again on the chat. Let service equal server. We resolve the promise of the server, and then s dot get primary service, and then we pass in the name of the service that we wanted, service. So it's the same thing as this one. So this one just filters, because if you do something like accept all devices or something like that, then it will show a lot of things because you wouldn't know, but a lot within your area, there's actually a lot of Bluetooth devices. So we want to get the primary service and we want to continue there, right? Again, promise resolved, etc. I'm going to copy this and paste this on the chat. Now, again, we're going down the hierarchy. We have your device, the actual device. It becomes a server. Underneath it is a list of services. We took the battery service. Underneath the service will be a characteristic. And so we want a characteristic. Let characteristic equals, again, it's a promise. So we resolve the promise. We want to get a characteristic. And the characteristic that we want to get is called the battery level, right? Again, it's a promise, so it hasn't resolved yet. And that characteristic will have a value. So let me copy this to the chat again. False characteristic. We resolve the promise. C dot read value. Again, this is another promise, and then we resolve the promise. Console.log v. Now v is going to be a type called array buffer, and so it's an array, but it's like a stream of bytes, and so we want a special view from that, which is an unsigned int 8, and we got 50. So if you notice from if you look at your simulator, it will actually, sorry, what was the last thing that I pasted? Okay, I will paste this as well. If you look at your simulator, it actually says 50. And that's actually what we got, right? A 50. So has everyone gotten to this point? All good? Yeah. All right. So that's a lot of like promises, but that's generally how it is. Because again, when you're this is why JavaScript is great in this case, because it's evented, and so sometimes your peripheral will not respond, right? Or will respond slowly. Then you need to still continue on doing things in your application while waiting for that. But so you are able to read, but what about writing? So it's a bit difficult to do this on the simulator because this simulator does not have it. But what we can do is I can show you this application that I did, a small thing, where I put everything in the script text. So this is the same thing, but except instead of then or something like that, like using the then promises, I just used async await, and it's just easier. Instead of like putting then over and over, you just await the thing, right? So it's the same thing. So instead of just reading, we want to write a value. And what are we writing to? So I will expand my camera for now. And you'll see that on here is a light bulb that I've programmed through Esprino. If you've been attending Penang JS, I have been doing a series of workshops on Esprino. So this one is running Esprino, and I did a small circuit here with new pixels that will accept like Bluetooth low energy commands, and it will basically display it as an RGB value. So I'll just quickly walk through the code so that you know what to expect. It's the same thing. Services 181C is the user data service because for some reason there is no UUID, like canonical UUID for LED bulbs. There's for heart rate, battery service, etc. You'll see that I had to specify user data service instead, which is not an LED light bulb, but we're using it like that. And we write a value, an array of 888888. So it's not really an array, a JavaScript array, it's an array of bytes. This is just a callback on the disconnect so that we clean up. You can attach an event listener on the device so that when it gets disconnected, then you disconnect the thing. This is just an hex to RGB. So from the hashtag 1234567 8, for example, to actual hexes, like actual numbers. And then this handle color change, we'll talk about we'll talk about the color picker in a bit, but basically on the color picker, whenever things change, this callback happens because of this particular thing. You'll see here, this is the color picker. When things change, then it sends that onto the light bulb. Okay? So I will connect to the device. It's the same thing. It's called the PAN 1780 722C. We pair it. You'll see that it's lighting up because I've set it up so that when something connects to the light bulb, it shines, it lights up, and we immediately send gray to the light bulb. It looks a bit blue, but this is actually gray. Right. So what we want is we want to write a color onto the to the light bulb. So we want to write, for example, this color, or this color, or this color, right? And this color. So we're actually writing this. So in the handle color change, we are converting it into an array of bytes that we're sending onto the Bluetooth Low Energy. So you'll say, okay, so it's sending things. But what's actually quite cool is that Bluetooth Low Energy is quite fast, that you can do something like drag the what it calls the cursor around while clicking, and it's going to like stream the changes onto the device, right? You can do it like that, and you can change the into the rainbow. So this particular color picker, I'm on Windows right now, so the color picker is not that great. But I think on a Mac, you have a nicer color picker, like the circle color picker. So that one is a lot nicer. But you'll see that it's changing and it's quite fast when you're changing things, right? So that's just like a light bulb. It's like showy. That's why I chose this. And when you disconnect from it, disconnects the color, the on disconnected events fire. And also again on the device itself, I set it so that it will turn off the lights when something gets disconnected. So if you would like to see the code for this particular light bulb, not for the light bulb, but for the web Bluetooth control, you can go to this website. That is the page where I like just deployed some sample code. You can take a look at it. It's ES6, so you will need a modern browser to work with it. Another thing, so that's on the computer, right? What's great is that you can run Chrome on your phone. You connect to the device. So same thing. You connect to the device. I connect here, it's here, and then I pair, and then it turns on, and then you have the same color picker capabilities, right? Except that here, because the color picker allows you to only set things, like you set the color and then you set it. So now, what this is one of the reasons why Apple does not like this is because when you have a web page that can connect to the physical world through Bluetooth, then what's the incentive to create native applications, right? Like you can have your remote control, for example, on a web page. You just visit a web page, and then you can control basically your Bluetooth low energy devices. So, and right now, again, this is a standards that is being pushed by the Bluetooth special interest group, Chrome, and because Edge now uses Chrome underneath, it's running. It's also available in Opera and Samsung Internet. If you want to know what is Tooth N, if you would like to know which devices are supporting Bluetooth, then it's Chrome Edge, Opera, Chrome for Android, Opera for Android, and Samsung Internet. So Firefox, Internet Explorer, not really. Firefox and Safari, not yet. Especially for the iPhone, because Apple does not allow third-party browsers. You might think that you're running Chrome, but you're actually just running Safari in your iPhone. So until Safari for iOS supports it, then we won't have this particular thing. All right, so that's a quick taster of web Bluetooth. There's a lot more. I haven't really organized everything. This is still really something that I'm exploring, but let me know if you would like to know more about this. There are a lot more things. For example, there are ways to stream data. So I'm streaming data into the device right now. There are ways for the device to stream data to me, to the browser, and then you can have graphs, for example. So for example, you can have a motion sensor that will detect the level, and then you can have a 3D controller, for example, on a game, something like that, on a website, and you don't even need to install a program; just visit the URL. So those are interesting times here. Now, but since this is a Ruby meetup, I would like to show as well something. So Ruby can also do this, but the thing is, because Bluetooth, it needs to interface with the Bluetooth hardware. It's less portable. Because for example, in Chrome, because it supports Mac, Linux, and Windows, then it's easy to, it just abstracts away the API, right? You have your Navigator Bluetooth property. But of course, in Ruby, you need to specifically communicate with the hardware. And in this case, unfortunately, we only, I only am able to interface with the hardware on Linux, which is why GUI, I was asking if you were on Linux, but I don't think we will have like enough time to actually try it. So there's a matrix that I'm trying. I hope I didn't destroy it. And then I have to run my Linux machine. I will open the code here, and while I'm running it, and then so that at least you can take a look at it. So this is a GitHub repository I'm using for experimentations with the Ruby thing, the Ruby Bluetooth Low Energy. Let's see if I can this run, then we can just walk through the code. Is it still alive? Yes, okay, so it's working. So now you can see, oh, you're not seeing it, sorry. Yeah. Okay, so this is a matrix. I will program again. Did it die? Here's the thing with live presentations with devices. Is it running? Yeah, it's running. So it's doing a color wipe. All right, and then I got disconnected. Cool. All right, I will quickly go through the code again. We're using a gem called BLE. It's using, behind the scenes, it's using something called Ruby dbus, which is, dbus is, how would you say it? It's something specific to Linux. It controls all of your devices and properties, and it's like a registry of things. And what we do is almost the same thing as we're doing with web Bluetooth, but it's just that the comparison here is that Ruby is it's not an invented language, right? It's you go from top to bottom in serial, and it's not even multi-threaded. You don't even do multi-threading here, so it's blocking. Each request is blocking. So what we do is the same thing as we did with Navigator Bluetooth get request devices. We do a discovery of devices, and we basically show all of the devices. I will show an output later because I have to mask all of the device IDs. We don't want to, you don't really want to give out the device MAC addresses of your Bluetooth devices because otherwise people can connect to them. But this one specifically, the matrix, I want to get that particular thing and then we connect. So it's the same thing, the parallel to our web Bluetooth where we did a GET connect. So this is the parallel, a GET connect. We do a device connect. And this is just like for debugging. And then for a characteristic, so this one is specific to dbus because it doesn't want to, because it does not know about the user data and the string. So we have to actually add that to its list so that we can connect to it later on. So this is just specifically there, most likely because the Bluetooth Low Energy library gem that I'm using is actually old and it doesn't have any of the new UUIDs that the Bluetooth SIG had updated. And same thing here, we have an RGB, but this time, because this is a matrix, we have an XY, right? So the format here is you send the R byte, G byte, the B byte, and then the X and the Y as a string of bytes. We pack it, again, it's in the counter to this on web Bluetooth is that it's an array buffer. So we want to pack it into characters. So it's going to be like a single byte for each of these values, and we write into the device. All right. Now, what I have a function here called, or method here called color wipe. which just goes from 0 to 7, and then 0 to 7 on the y-axis, and then we just write like different colors of RGB. So first it's like empty, and then because this is a loop, where is X? Where did I define X? So basically it's X is going to be like increasing, and so it's going to be first all red, and then all green, and then all blue, and then red and green, which is yellow and blue. So it's going to be like cycling through all of that, and then we of course we disconnect these things. So this is the Ruby version. I haven't really been working with this so much because it's a bit clunky right now. The implementation, Ruby does not have a lot of libraries that interface with the operating system, and that is cross-platform. Like I mentioned, this is only for dbus, for example, like this particular gem. I haven't found anything for Windows. I don't have a Mac, so I wouldn't know what is specific for the Mac, like if there are any Bluetooth gems. I think in Node, they have the NoBLE, the Noble package, which rides on the cross-platform bindings by Chrome. So
just
if you would like,
comment, if you could zoom in to the code a bit.
Sure. Zoom in. Yeah. So what I can do better than that is I will paste it on the chat. So you can actually take a look at this. If you'll see, this was since July 30. I haven't really been working with it, but maybe like this was like a few months ago. Maybe the environment has matured in this case, so we'll see. Otherwise, then I'll figure it out. Like I'll find out how else to present this in a more cross-platform way instead of like switching computers. Because right now I'm on a Windows machine. I was running a VM and trying to do a pass-through of my Bluetooth dongle, but I wasn't having any success on that. So maybe next time. But for now, this one is definitely there. It's a web Bluetooth has been there since Chrome 56, I think. Yep, Chrome 56. So if you would like to use web Bluetooth on your applications, then you can already do so. It's not that complicated. It looks complicated because of all of the promises and the chains that you have to go through, but the ES6 async await format is quite nice. It looks as if you're just like doing it the way you would do it on Ruby, right? Like from top to bottom, and then you have like all of your catches here. So yeah, that's it for me. I hope you like the presentation, the mix presentation.
What was the original like use case that you had when you like got into this Bluetooth?
I've been doing software development for many years now, but I did not graduate as a computer science student. So I did not actually do engineering or computer science or all of those things, right? So I wanted to go back to the roots, as you may say, because like the roots of software is actually hardware, like transistors, all of these things. So I've been learning about circuits. I've been learning about all of these small things, like the hardware side of things for quite some time. And because along the way, then you notice, oh, there's this thing called Bluetooth Low Energy. And I guess the advantage here is because I was a software developer, I did websites, and I knew about web Bluetooth, and I was also discovering hardware. Then I know how both of them work. So it's, and by the way, remember the light bulb? Where's the light bulb? The light bulb thing. So the Esprino thing, firmware. It's actually let me go to my Meetup page. It's actually written in JavaScript as well. So let's see. I think I will put the code. I think it's the so this is the code that is running on this light bulb, that on the PAN 1780 development board. So you'll see here, for example, that these are just helper functions. This is paint, which is like because there are so inside here are actually 7 neopixels. So I want to paint all of them with the colors. And what's strange is, for example, you'll know about RGB, but the encoding scheme here is actually GRB. So there's like, that's why I have to change it a bit, the order a bit. And then you basically set the connection interval. You'll see here, these are the services that I was just like showing in the web Bluetooth side, the browser side. And then when you receive something, you just write that color onto the neopixels, to the addressable RGB. And it's the same thing. So this is what was causing it to turn off when you disconnect. You basically write an empty array of zeros onto the neopixel side, and on connection, it will fill it with a slightly darker gray. And then when web Bluetooth is finally initialized on the browser side, it will be a bit brighter, but still like light gray. So this is actually the code that is running on that light bulb, and it's also written in JavaScript. So it's an interesting thing. So lots of the things that you learn as a software developer can also be applied to hardware, and probably you probably have an advantage as well if you're coming from software into hardware, because you have a lot of domain knowledge that many of the hardware people don't have. So yeah, so that's like a small story of how I got into all of these like hardware things,
Right.
hardware stuff.
I was wondering that you had something that you didn't want to do and you kind of wanted to automate, which got you into this rabbit hole of.
Well, yeah, the best thing, the best way to learn something is to actually have a project. So that right now I have I have one here, like these things, like fobs that you can click on. Like these are Bluetooth, and I've actually set up things with sonoffs around the house so that this one is not activated, this one doesn't have a battery, but when you press it, it actually turns off either the lights or the fan or all of them. I think I have am I still sharing my screen? All right. Let's see if I can. I think this one. So this is the room. This is my room. This is the same thing as here. And it's just without the thing. So this is like a Bluetooth remote control of what this is the light and this is the fan. So that's another practical application of these things. So this is just running a Wi-Fi bridge connected to MQTT. This is like advertising things. Again, that's a different thing. That's a Bluetooth Low Energy term. Advertisement, which is a broadcast type. So it's just broadcasting like commands, and then a Raspberry Pi is just receiving it, translating it into commands onto the sonoffs, the Wi-Fi bridges. So again, lots of things, lots of projects that you can try out with Bluetooth Low Energy.
Nice. If I have any questions about Bluetooth LE, I know who to look for.
Oh, you can, again, Bluetooth Low Energy, everything is here. Bluetooth Sync, it's actually quite a good, well, not Web Bluetooth. Web Bluetooth is something else entirely. So if you have Web Bluetooth, Google, where is this? Google has a lot of samples here. Like for example, battery level. you have all of your dens here, for example, and then you have your async await, which is a lot nicer. If you remove all of the logs, for example, right, you'll have like your device, it's the same thing. So you request the device, and then you connect, get the primary service, you get the characteristic, you read the value, and then it's basically your battery level. So it's the same thing that we were working with. It's just that we were doing this one, the promise, the then way, not the async await syntax. So everything, like lots of examples on the Google Chrome.github.io / where is it? /web Bluetooth. Chat as well. There you go. Yes.
Right. Thanks for the wonderful showcase, Tristan. Let's see. Well, that's kind of like the last talk of the night. I guess before we end, we can kind of like, we're always looking for speakers. So anybody watching this right now, if you're interested in speaking, reach out to us. We are always on, as I mentioned earlier, Slack is definitely the place to reach out. So definitely come join Slack and talk to us if you ever want to give a talk. I guess that's it. Ruby 3 is coming out next month. Kind of excited about
We'll
that.
see you as well next week. I think when is the next Ruby Tuesday?
Next month, definitely.
Where's
Probably will be
Next
1st of
month.
December.
Yeah, the 1st of December. So if you have anyone like to talk about Ruby or like their adventures in Ruby, like just ping us on Slack or on Facebook or here, like on one of the comments on YouTube, then we'll make sure that you have the slot for it.
Yeah, I think Ruby 2.7 should be Ruby 3, right? The latest.
I don't know if 2.7 is 3.0. I think are they just like promoting 2.7 or are they creating a new bump? Like, are there like commits in between?
I think they're going to ship 3.0 as 3.0 because I think 3.0 preview one is out already.
Yeah.
Okay. So it's a transition. Looks like it's a transition.
I don't think there's a lot of breaking changes compared to 1.9 to 2.0. So, but we'll see.
Well,
we'll see.
Maybe if anyone wants to do a talk on December 1st on what to expect on 25th of December, then that would be great. I will be listening there.
That would be good.
Okay, I guess we can kind of end this. Thanks everyone for joining us. Thanks Tristan for the talk as well. Kui for joining us. All right.
Thank you, everyone.
Bye. See you all next month.